Ladies and gentlemen, welcome at this side event. This is a side event on science for informed mitigation and adaptation choices. I won't say much at this stage, but it's important also to recognize that this is a joint side event between the World Meteorological Organization, the International Atomic Energy Agency, the Food and Agricultural Organization, and the World Food Programme. But we also had contributing organizations, IOC, UNESCO, as well as UNEP involved. And with that, I would like to just introduce the facilitator for this afternoon. Many of you might know him. He's Dr. Martin Frick. He's Director of the Climate and Environment Division at the United Nations Food and Agricultural Organization. Martin has got extensive experience as a diplomat and negotiator, and also played a key role in the establishment of the UN Human Rights Council in Geneva. When we looked for a facilitator, we had a unified view amongst all the organizations that he would be the best guy to facilitate this afternoon. So with that, I give it over to Martin.
Thank you very much, Dean. And you're not making my job easier by raising the expectations, but I will try to facilitate this panel. We're here today to speak about science and how science can support mitigation and adaptation efforts. And I think it's a good moment to recall that we wouldn't be here and there wouldn't be a UNFCCC convention without the role of science. And it's worthwhile basically underlying this point that while all of our work is based on science, and IPCC did a tremendous job in actually providing the evidence based for it, we are living at a time where at the same time science is challenged. And we know about the phenomenon of climate skeptics, and I'm always reluctant to use the word because skepticism is a good academic quality, but we're not talking about people who are basically double checking their facts, but people who are ignoring the facts and putting climate change in the realm of beliefs. And I would be maybe the person most relieved if climate change would be a question of belief or disbelief, but unfortunately you can't negotiate with nature, and it's a fact. So acknowledging this, we had a remarkable publication in the recent period, which is the encyclical letter of Pope Francis, Laudato Si. And for someone interested in the history of the Vatican, I found it very refreshing and heartening to see world-class scientists on the panel presenting the encyclical letter and making reference to the scientific work. So while a faith group is basing their decisions on science, other people want to try us believe that the science actually is not science, but a matter of belief. Fortunately, the Paris Agreement called for the best available science, and indeed it's absolutely remarkable what happened in terms of scientific progress over the last years. So today we are going to look into three different aspects of how science can support decision making. Firstly, on the origin side of the problem, how can we see and monitor what is invisible, which is the CO2 emissions? Secondly, we're going to look into what a higher level of CO2 does to the oceans and what strategies exist to adapt to that. And thirdly, we're going to look at a human level, at what does it do to local communities and how can scientific data and evidence support building resilience of communities on the ground. Let me start with our first intervention coming from Phil DeCola, sitting right next to me. Phil is an adjunct professor of the University of Maryland and works there in the Atmospheric and Oceanic Science Department. In his career, he has focused on remote sensing. That's precisely what he's going to speak to us about, and has been advised the White House and the two administrations. Let me just set up your PowerPoint presentation. Okay. Phil will speak to us about how we can actually find out what really is going on in terms of CO2 emissions, where we have a global picture, but what we need is a more granular picture. And we need it specifically in the context of the nationally determined contributions and for the transparency framework to really understand where the emissions are coming from. We underestimate emissions, but also, as I know from a discussion yesterday, where we might actually overestimate our emissions. And without much ado, Phil, I would give you the floor to speak to us about your work. Phil, you have the floor.
Thank you very much, Martin. Can everyone hear me okay? Great, thank you. So before I begin my presentation, I want to point out to you that we have some copies of this year's WMO Greenhouse Gas Bulletin up to the right side of the podium as you face the podium there. And if there's not enough for those who wish to have one, we can allocate some more. And this is something that WMO releases every year that tells you the state of the atmospheric concentrations of all of the gases in the basket of gases that are being considered by the UN Framework Convention. And this particular issue this year has an article in the center, a 2-page summary of basically what I'm going to introduce to you today. And so if you're interested in learning more, you can have a look there and the references that are supporting the description. And also, of course, myself and Diane Terblanche, who kicked us off today, and Oksana Tarasova from WMO, all of us are available as points of contact to talk with you more about this opportunity. And in fact, to start off my presentation, I first want to point out that you see some names here. These are highlighted on the cover slide because they've contributed in detail to these slides I'm going to use today. But there's a large group of folks that are part of this team, the Integrated Global Greenhouse Gas Information System. It's abbreviated I, and you know the GIS, right, is like a geographical information system, but this one is raised to the 3rd power, okay? And so it's the abbreviation for this initiative. And the whole point of my story today is to measure the atmosphere to manage better the emissions, okay? And so I want to say that we have a large team. I'll just mention a few folks here. Vincent-Henri Boyche, who is the head of Copernicus at the ECMWF in the UK, Alistair Manning from UK Met Office, Christoph Gerbisch from Germany. You see that this is an international team from all around the world. We also have a number of colleagues, Mashida-san from Japan, and many others from all of the continents. And this group of scientists worked together over the past year to look into what skill we have within the realm of atmospheric and carbon cycle research that's ready for prime time today to help us guide us along mitigation solution pathways. And really the whole message is summarized right here, that we can't really do a good job of managing these affairs without having the best possible measurements. And the question up above is really, I think, being answered here all around us today at COP22. The answer is yes. And here's the whole summary of this message, that currently today, the IPCC Task Force on National Inventory Reporting has developed excellent methodologies for using statistical information, activity data, and emission factors to evaluate what the emissions are and help nations who are able to implement these methods according to either tier 1, 2, or 3, tier 3 being the highest and best certainty approach. And so they have published in 2006 guidelines for how one goes about doing these, building these inventories. And what's happening now is they're entering a phase of updating those guidelines. And as part of that update, which will be released in 2019, they are now going to be adding, as part of the protocol for building and evaluating inventories, the so-called top-down. Oops. So-called top-down. We call the statistical methods bottom-up. And by adding comprehensive atmospheric observations and inverse model analyses, and also some remote sensing of activity data on the land to improve the activity data where databases aren't available, we're able to add those two together to get improved posterior knowledge of the emissions. And I'm going to now go into a bit more detail from some specific areas about how that's actually going to be accomplished. And ultimately, these are some of the ways that we help to facilitate the work of countries as they want to understand the efficacy of their current pledges being met, and then how they want to, over time, do better. And also critically important to this whole story is what's happening with the response of the Earth system. As most of you in the room know, we currently have roughly a 50% benefit that's a freebie to us because of all of the fossil fuel CO2 and emitted into the atmosphere from human activity. About 50% is absorbed by the land and the ocean. And the question is, and we know from detailed analysis of that, that's on average 50%. Some years it's 90%, some years it's 10%. On average it's 50%, and it's been steady like that for quite a while now. But who's to say that that benefit is going to continue over time? So why do we have a UNFCCC? Well, there are many reasons why, but the bedrock reason why I assert here that it's the evidence-based information, the famous Keeling curve that shows the geometric rise in concentrations of CO2 due to our activity, and the response of the Earth system in terms of all these different records showing in sync the rise of global temperatures. And going back to looking at where we were with the process in 2009 in Copenhagen, at that point, some people considered it to be not a success because we didn't get an agreement out of Copenhagen. But this was the beginning of the idea of a pledge and review approach, which really is why we've been so successful of late. And so it was more of an aspirational, bottom-up approach. Also at that time, the scientific community had a naive notion that we could come along with satellites and aircraft and other measurements and say, well, we can then use our observations of the atmospheric gradients to tell us what is really happening in the system. And that wasn't very helpful to the political process. And it's actually one of the reasons why the Copenhagen discussions broke down. And now we have a Paris Agreement because of this aspirational approach that was taken, and there are pillars of the agreement. And some of the detailed examples I'm going to show you today align with these three in bold, and we're going to discuss that in a little more detail. And I show this slide again because I want to show that the science community, the atmospheric science and carbon cycle science community, has evolved in their approach as well. And that's being represented in the IG3IS initiative. And so here, what we're now saying is for those countries and those subnational entities which wish to take advantage of this additional information to help them manage in a non-crisis management mode, but with more detailed information about what's working and what's not working as well, we can contribute to that with enhanced information. And these are some reports that were released back in 2010, which had this naive notion of the value of verifying from the top down. And now, like I showed on the slide before, we're taking a combined approach of saying, let's bring all of the best pieces of information together. Let's not try to say we can verify one from the other, but why don't we use the best information we have to guide us in the work we want to do? And so that's the philosophy that we're taking. The first bullet there has lost some of its words, apparently, but basically that's what I just said, though. So I don't need those words because I just said that. And then the important part of this is that we don't do like many scientific reports that have been generated over the years and just get together as a science community, generate a report, and throw it over the transom and say, okay, read this and get wise. Instead, we're engaging with the potential user communities right up front, and we want them to help us identify where our skill can help us bend curves that wouldn't otherwise bend in greenhouse gas concentrations. And of course, the situation will evolve with policy and capability, and we need to maintain standard methods so that a kilogram that's reported in one place on the Earth is equal to a kilogram someplace else. And so we have a level playing field. This is being done under the auspices of the WMO Global Atmospheric Watch. Within WMO, this is a sponsorship also with UNEP, just like many other great initiatives of the past, like the IPCC itself, for example. Why WMO should play a role in this? Well, they make the standards for greenhouse gas measurements up around the world in partnership with the National Oceanic and Atmospheric Administration and others. And also, this is a weather problem. This is a greenhouse gas weather problem. Here you can see that in this one location in Boston, at the 1 a.m. in the morning, the concentration of CO2 had peaked, but the emissions are dropping, and it's still staying up. And then as the rush hour begins in the morning and transport emissions are going up, 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 the concentration's going down, down, down. Why? Are those two things anti-correlated? We expect them to be correlated, and the reason, of course, is the sun came up. And the turbulence at the surface of the Earth is increasing the mixing volume of the atmosphere. The boundary layer is growing and diluting those concentrations. So not only do we need to use the detailed knowledge of atmospheric concentration, we also have to have a great knowledge of atmospheric transport. And we have 4 objective areas. I'm going to touch quickly on a couple of them. We have 2 lines of activity. We are implementing pilot projects that are being funded by various international bodies like the Green Climate Fund and the World Bank, to give 2 examples. And we're working with developing countries in particular to develop skill they need to understand their pledges better and manage the growth of their society that's needed to increase the well-being in many places in the world. At the same time, trying to do that in a way that reduces greenhouse gases, and that's quite a challenge. So, okay, so the first one I want to touch on is national inventory reporting. In the UK and in Switzerland, they're already taking advantage of the combination of atmospheric measurements with statistical data. They have 4 locations where they make tall tower measurements of a number of gases. They use an inverse modeling approach that shows, this is the Mace Head location in Ireland where measurements are being made, and they look at the back trajectories of the air to identify where that air came from that's being measured. And then they go through an iterative process to compare the measurement to what the model says should be the measurement based on where the emissions came from. On this day in particular, you can see there should be very little influence from the UK on what's being measured. All of the footprints here are coming from out in the ocean. But there are many other days when it's quite the opposite. And here you can see an example of what Martin had referred to. This is the report on the fluorochlor... what? Oh, sorry. Thank you, Dion. This is what the green dots here show what the United Kingdom has reported on HFC 134A, which is a mobile refrigerant and a powerful greenhouse gas. You can see they were reporting this amount over time. And here you can see what the atmospheric inversion, taking the concentration measurements, the red from just the Ireland station, which was in place for a long time, and now the blue with all 4 stations. And you can see that the UK was reporting about 50% more than what the atmospheric inversion said. Now, which one is right? Well, the answer is neither one is right, of course, but you have an indication that something is amiss. And the inventory builders have begun looking for what emission factors might be off, and they're beginning to come more in agreement. The red, which is the most recent report, has come more in line, but is still outside the error bars. So there's more work to do, but you can see that the combination of information is getting us towards more certainty. Here's another quick example. How much time do I have, Martin? How am I doing? I have 30 more minutes? Okay, good. Okay, so here you can see in the case of Switzerland, they are also using a combination of atmospheric measurements and statistical data. And here's a case for methane. You can see that these X's here are the stations where measurements are made. This is the prior inventory, the bottom-up information placed over the model grid. You can see the grid cells are bigger as you go farther away from the measurement sites. And then after you do the inversion, combining the bottom-up with the top-down, you get this field of emissions, and you subtract the 2. This is the absolute difference. My pointer is failing me here, but this is the absolute difference on the left and the percent difference on the right. And you can see that here in the center of the country, one of the, I neglected to say, one of the great results of this is, turns out in this case, that the total emissions of methane for Switzerland were in agreement. The prior agreed with the a posterior assessment in total. But what happened is the uncertainty came down by 50%. So we had a much better assessment of total methane from Switzerland as a result. But you notice that spatially, there were discrepancies. In the center of the country where they were over-reporting, and up here in the Northeast, they were under-reporting. You can see that by this, the blue here and the orange colors here. And as a result of that spatial knowledge, they were able to now look at different practices in dairy, and they were able to identify potential opportunities for methane reductions in the dairy sector of their sources of methane in Switzerland. So that's another example of how the atmospheric information is helpful. And then here, as I already told you, the planned 2019 methodological update of the Task Force on Inventories of the IPCC is including these kinds of techniques. And this will both help developed countries report in a more certain manner and also identify mitigation opportunities. Moving on to subnational efforts, which are a pillar of the Paris Agreement. We have also identified as an objective area ways that we can use atmospheric measurements to help cities with their efforts to reduce their emissions of greenhouse gases. Why is that important? Many of you know that greater than 70% of fossil fuel CO2 comes from large urban centers of activity. You can see this from the Edgar inventory here. Also, this is where the political will has been quite high for some time now, as evidenced by activities like the C40. In addition to that, this is where either the problem or the opportunity is increasing. You have some cities here, like LA and Paris, who have very ambitious goals to reduce their emissions. And it's also where, as many of you also know, urbanization is increasing dramatically around the world. And we tend to look at that as an opportunity for high quality of existence and low emissions. It's where the tuning knobs are: building efficiency, transportation efficiency, energy efficiency. And also, it's where the signal is strong. If you want to use the atmosphere, you can see that at the 100-kilometer scale, the signal gradients, the gradients in the atmosphere are weak. As you go down to 10-kilometer and 1 kilometer, you can see that on the same scale, the signals are stronger. And we have a number of projects underway in Los Angeles, Paris, Boston, Indianapolis, Recife, Brazil, and we're in discussions now with Mexico City, Seoul, Korea, and a number of other places around the world who want to start to duplicate these measurements and enhance information opportunities. Here's LA. You can see from this chart that transportation, not surprisingly, is the biggest source of CO2 in LA. And here's a result from Paris, from Francois-Marie Brion is the first author. And here you can see during the morning and afternoon, by combining atmospheric measurements with spatially and temporally explicit bottom-up information, you get this is for the anthropogenic sources in red. You can see this is the prior and the a posterior. The error bar shrinks and you have a reduction in what the assessed value is. Same in the afternoon. And in the afternoon, we don't really get that result for the biosphere, which is in the green, prior and a posterior. And that has to do with the fact that we need more C14 radiocarbon analyses to add in so that we can distinguish between fast and slow carbon in the atmosphere. And I'm not going to go into detail on that now. I'm going to skip this one, move on to methane from different sectors: waste management, agriculture, and of course, oil and gas supply chain. And here, why is methane so important? Well, you can see that from the reference scenario here, if we don't do anything, we're toast, of course. But if we just do CO2, you can see in the near term, in the 2040 timeframe, we fail to really be on track where we want to be if all we're addressing is CO2. So in the near term, there's this big opportunity with black carbon and methane and other short-lived greenhouse gas forcing gases, so that we can see that we can get to our goal here ultimately if we do both the long-lived and short-lived greenhouse gas forcing. And we've had some success in identifying super emissions from the methane from the oil and gas supply chain. This is some work that was done in the Barnett Shale in Texas that was sponsored by Environmental Defense Fund and the National Oceanic and Atmospheric Administration. And they were able to show that we can find these large, previously unknown big leaks. They're fat tail events, low probability, high consequence events. And so by combining improved bottom up and top down together, and here's an example where we take this beautiful tiered approach. We start with a satellite observation from GOSAT that showed a hotspot here in the Central Valley of California. We then did a mass balance measurement flying upwind and downwind over the facilities, the oil and dairy facilities in that region. We identified that it was this Taft Dairy, and then we flew with an imaging spectrometer and we could identify exactly where the plume was coming from. This is a direct detection that's very powerful demonstration of how this information can help guide us. And in Los Angeles, we recently had another example where we had a good understanding of where the potential sources were, but our inverse model showed us that we had actually a big source right in a neighborhood that was surprising to us. We flew over again with our imaging spectrometer and confirmed indeed there was a huge methane leak there. And it turned out that a big distribution pipe had burst. And we reported that to the utility. They fixed it. We went back and flew again, and it was gone. So that was a case of averting a potential disaster. But you can see again that this has applications for mitigation. Now, this is the final example, and I have TBD here because the UNFCCC process has not really clearly identified how global stock taking is going to take place. But again, we see the potential to provide some helpful information in that process. We need to know, what path are we really on? Are we missing the mark? How much are we underachieving over time? Or are we on target? And this kind of, obviously, I think we would all agree that the best possible information is what we want to have in our toolkit. And we don't want to eliminate this powerful additional information from the considerations that are being made. Ultimately, again, like I said, this is like air quality. Air quality is a chemical weather problem. You need to know the criteria of pollutant concentrations, but you also need to know how they're moving and how the photochemistry is taking place in the atmosphere. And although these are not reactive gases, transport in the atmosphere is still critical if we're going to be able to use atmospheric concentrations. And here, just like how there was an evolution in skill with numerical weather prediction over time, we imagine that through efforts like Bernard Pinty pointed out in our Earth Info Day a couple of days ago, that satellite systems and advanced data assimilation systems will even increase our ability to do the kind of work I'm talking with you about today to a greater extent. This is a nice dream for the future. And then just to review quickly, 2 conclusion slides, that our goal with the IGUS activity is to provide capacity building to the developed world and also capacity in developing world and also capacity building to the developed world, both, and to help facilitate the pledges of those who are interested in working with us. Nobody's being forced to do this. This is just a complement to what they're already doing. And then also here you can see a couple of other conclusions that we are basically trying to work in concert with all of these different partners and trying to help the process move along as best we can. I'm running out of time. So here's a final conclusion slide, that our goals here are being developed on 2 main pathways of development. One are guidelines under each of these objective areas so that there will be available documentation for how a country or a city can implement these kinds of capabilities. And then also pilot projects, confidence that users are really getting improved information and making improved decisions on the basis of that, and bending curves as a result. That's our ultimate goal. That's our ultimate success criteria. And we have a number of partners. Some of them are listed here. The Group on Earth Observations, GEO, on the far left of that list, has also some activity along these lines. Of course, GCOS is leading the way in helping us to define where the observational needs are. So we're partnering with them to make sure they're guiding countries to what observations are critical. This is a service. This is a climate service. So we're working with GFCS as well. And IPCC, as I said, they're trying to update their ability to help countries do the best possible job of inventory development. So that's it. And I'm happy to answer some questions afterwards, after my colleagues speak with you. Thank you very much.
Thank you, Phil, for the fascinating presentation. I hear two political points here, which I just wanted to. Number one is, of course, we hope in the pledge and review system that is on the basis of the Paris Agreement that countries take the initiative. And of course, we hope for strong commitments by the country. New scientific methods, that there would be a positive peer pressure also to use cutting-edge technology as you just presented. The second thought is that you mentioned the importance of megacities, and megacities are politically also most interesting because these city centers are and always have been a center of progressive thinking. So if you just look at some recent elections, and I don't need to go into more detail, you can see a difference between urban population and rural population. And if you can really bring it down to your city and what the city can do, and where there is a limited group of people that can actually quite directly decide about what's going to happen in the city, I think then you're up to a big part of the solution. And the example of the methane leakage shows immediately how that makes sense, and the astonishing quality of really going down to the detail of the emissions. And I think that's opening also in the context of the global action agenda, which is, of course, becoming more and more important as we move to the implementation. I think a very interesting bit. Phil, you wanted to comment?
Just very quickly, Martin, thank you for those 2 points. And a point of emphasis is that up until now, the atmospheric concentration measurements have been done with a focus on the global background to show, because of course this is a global problem. But now as we're getting into the solution set, the kinds of activities here are showing you that we need the same quality of observations where the action is, where the emissions are, where the tuning knobs are. And so this is an evolution. We still need to look at global background, but we are now moving into a time when we really need the best information about where the mitigation opportunities are.
Thank you very much. Our next speaker is going to continue exactly in the same vein of global problems, but also local solutions. Libby Jewett is the founding director of the NOAA Ocean Acidification Program since May 2011, and also founding member and co-chair of the Executive Council of the Global Ocean Acidification Observing Network. Now I got this one right. She has a PhD in biology, background in marine ecology from the University of Maryland, a Master of Public Policy at Harvard University's Kennedy School of Government, and a BA of the Yale University. And if you're not impressed yet, you will be. Libby, you have the floor.
Thank you. Thank you. And I, first of all, want to thank my colleagues at the IOC and IAEA who I believe put my name forward, and then to thank the WMO for inviting me to come speak today. So I just, before I start, want to say, as director of the National Oceanographic and Atmospheric Administration's Ocean Acidification Program, I am a marine scientist at my core, but I'm also very focused on translating scientific information to policymakers, both for the development of scientifically robust policy responses, but also to expand resources that are needed for the science. And so it becomes this sort of reinforcing circle. If policymakers don't buy into the need for the science and the data, they're not going to expand resources, financial resources to make them happen. So, and definitely I'm going to play up a couple of Phil's things about what you can't measure, you can't manage. That's definitely an important part of what we do. And this global versus local measurement, very much what we're focused on as well. So hopefully, oh wait, let's go that way. Okay, I got it, yeah. So in terms of my outline, I want to briefly mention the Sustainable Development Goals that are relevant to our ocean acidification work. I want to tell you very briefly, if you're not aware, what ocean acidification is. I want to tell you an OA adaptation story from the United States. I feel like I tell that story all the time, but I'm always surprised when I find people who haven't heard it, so I'm going to tell it again. And then talk about how understanding ocean acidification really requires a multidisciplinary global scientific partnership. And we're seeing a very strong partnership that's grown up over the last couple of years related to ocean acidification. And then I'm going to end with talking about coral reefs. I know very important for many areas, especially less resourced countries around the world. I want to talk about partnerships that we're developing there and also potential adaptation options. So the relevant Sustainable Development Goals are 14.3, which is focused on minimize and address the impacts of ocean acidification, including through enhanced scientific cooperation at all levels. And then, of course, 17, which is the focus today, which is strengthening the means of implementation through partnership. And I feel like that's sort of like the implementing strategy for all of the other SDGs. And I'm very honored to be a part of this process. So what is ocean acidification? Well, I like to say, and Phil already mentioned this, what goes into the air also goes into the ocean. And about 27% of CO2, of course, averaged across years, is taken up by the ocean. And that was seen as a really great thing because it actually moderates the impact on climate change. However, it comes at a cost. So as the CO2 goes into the ocean, it actually combines with water and creates carbonic acid. And it's that carbonic acid which is increasing the acidity of our world's ocean. It's both a global stressor, but it has local effects. And so we need to know what's happening globally, and we have a fairly good idea of that. But we're also finding out as we look more closely around our coasts, that how ocean acidification affects those coasts is very much related to the oceanography, to people who are living there, to river runoff, to precipitation, to upwelling. And so ocean acidification is not sort of one thing everywhere, and thus the importance for understanding. So I'm going to start with a good news story, which is from the United States, a story of adaptation, and it's very much about data and partnership. So here we have some of our friends, the larvae, small, tiny Pacific Coast oysters. And starting in about 2005, so all of the oyster larvae for our Pacific Coast industry comes from two hatcheries in Oregon and another one in Washington State on the West Coast. And those larvae started to die en masse. And we could not figure out what was going on. Was it viruses? Was it bacteria? Was it oxygen? And scientists were testing these and finding that those were not the culprits. And so there was a big question. And it wasn't until we brought scientists who understood what was happening globally with CO2, with industry owners, hatchery owners, and said, maybe what we're seeing here is the beginning of serious economic impacts that are being caused by CO2 for our marine resources. And in fact, that is what we determined. So it took this combination, this multidisciplinary partnership to solve this problem, at least for these hatcheries. And what's happened, so here you actually will see, you see a graphic on the left-hand side is a healthy oyster larvae, day one. And on the right-hand side is an oyster larvae that's been exposed to low pH waters. And that oyster larvae is likely not going to survive. We see malformations in the shell. Their metabolic repercussions, and that's the story. We connected that with certain conditions that happen certain times of the year off the US West Coast, which bring high CO2 waters that are now enriched with man-made CO2 into those hatcheries. And when that happens, the larvae die. So when we know those waters are coming on shore, we can actually tell, the industry now knows to either buffer the water, they're checking the water all the time, they can shut down their intake pipes, and now the industry has come back. So the hatcheries are now fully functioning again. So this is a good news story, but it's in contained systems. So how do we take that to the field? Now I'm going to talk about the important international partnerships, and we'll come back to the field again when we talk about coral reefs. So two very important entities that I want to discuss. One is the OA International Coordination Center, which sits in the IAEA. Very, very important effort of, again, multidisciplinary scientists and policymakers, government representatives. And then in addition, I want to talk about the Global OA Observing Network. So announced at the Rio +20 meeting, the IAEA launched the Ocean Acidification International Coordination Center with resources from many, many countries. And this effort is growing. It's looked to for information. They have an incredible website. They have if you want information every day sent to you about new papers coming out on ocean acidification, go to their website and sign up for their blog. It's an incredible entity. The ICC is also was one of the founding organizations for what we're now calling the Global Ocean Acidification Observing Network. Go on. It's not a great acronym, but I don't know. We didn't plan that very well. So there, go on. Yeah. But there it is. So the goals of that, the go on are, goal 1 is to be collecting and integrating data so that we understand how the chemistry of the ocean is changing. And that's not just, a few sets of data. Again, because of what's happening along our coast, we need the local to the global data. Goal 2 is also tracking the response of the biology. And this part we're still wrestling with exactly what the standardized methods will be. We've been meeting for a number of years, and we feel like a success because we've brought the chemists together with the biologists, and we're actually having really productive conversations after a lot of like, I can't talk to you, it's too confusing. And we're also making sure that that information is available for the development of models. We have a website, and within that website, you can now click on and be sort of transported to a new ocean acidification data portal. And again, we talk about the importance of data for policymaking. Our goal is that every platform, so this is what will come up when you go into that interactive data portal. In the background, you're actually seeing a measure of the corrosivity of waters that's sort of integrated from lots of different data sets. And you're also seeing all of the platforms where scientists are collecting OA relevant data. Now, at the bottom of the graph, you'll actually see, so on the very right-hand corner of the map, you'll see a mooring that's in yellow. That's in the Chook Lagoon in the South Pacific. And below, you're actually seeing, well, not real time right now, but if you click on there, you'll see real-time data coming from that mooring with the ocean acidification relevant parameters. And the goal is that eventually you'll be able to click on any of those platforms and be able to both visualize and get access to the data. So this is a very important part of sort of actually operationalizing our intentions. We have within the Go On, we have this nested system of looking across different ecosystems and then goals and different levels of measurement. So there's sort of something for everyone here. I would say SDG 14.3 is very much focused on goal 1, level 1. We also have a requirements and governance plan, which we put together through a series of international meetings. So there's, and the IOC has been very involved in leading the work on SDG 14.3 criteria and methods. So in terms of platforms that are on that map, we have ship cruises, moorings, we have gliders, but even more importantly, we hope that soon we'll be having more nearshore OA observations. And what you're seeing here on the left-hand side is a picture from a very recent July 2016 capacity building workshop in Mauritius. And on the right, it's a little hard to see, but there's a new low-cost sensor, pH sensor, has been developed as a result of the X Prize, and is now in the process of being commercialized. And the X Prize winner, Sunburst Sensors, was actually there to train this group, and that sensor is now sitting off the coast of Mauritius. So the intention is that we expand access to these low-cost sensors and expand data availability. And this is our somewhat complicated governance structure, but basically we didn't want to start anything from scratch. We're trying to integrate all the different groups that are working on ocean observing, and all of these groups, especially the ones that are highlighted in color, are actually contributing resources in some way, either people or financial resources, to make sure that we can come together and make decisions as a group. And very excitingly, as of September 2016, everything in green are scientists from new countries that are now doing will eventually, if they're not doing now, ocean acidification observing. And so we have 330 scientists that are contributing to the network from 67 countries. So we are working together. Next, I want to talk about what this means for coral reef ecosystems. So why care about coral reefs? Well, corals build skeletal structure from calcium carbonate. And calcium carbonate is the very thing that is in peril as a result of ocean acidification. It can actually, and it's more complicated than that, but long story short, from many, many studies that have been done on different coral reef species, it does appear that they're highly vulnerable to ocean acidification. And they're and coral reefs are very important for a number of reasons around the world. So within NOAA, and we have a lot of Pacific islands that we, in our sort of territory, have developed an approach for tracking changes in coral reef ecosystems that are relevant and affected by ocean acidification. And so it was supposed to be sort of moving, but long and short is we're hoping to eventually, have a Keeling curve that's related to the biology, and that is probably tracking the changes in calcium, in carbon dioxide in the atmosphere. And this requires actually doing a fair amount of biological observation. But we have taken this methodology to the Western Pacific, countries such as Indonesia, Malaysia, Philippines, Vietnam, and had meetings under the auspices of the Westpac IOC to sort of share this methodology. And I would say that the group overwhelmingly response was positive. And so this is a way to sort of expand scientific monitoring data by sharing the methodology so that we can then cross compare the data. And so as you'll look at the sort of Pacific Ocean, the NOAA National Coral Reef Monitoring Program is covering those particular islands. The NOAA and USAID are funding monitoring in those particular areas. The IOC Westpac, which are a number of other countries, are now implementing the same methodology in those countries. And soon to come on are Pacific Island, small island developing states, where we're doing, in addition, some capacity building, and there'll be training workshops coming up this year. So why do we need data from everywhere? Well, again, as Phil said, there's sort of the global picture, and then there's the local picture. And so if you look here on the upper right-hand side, and just don't worry about the specific unit, but the legend, if it's more purple, it's sort of less corrosive water, and reddish is more corrosive water. And we look at American Samoa, where we've done measurements all around the island. Well, not even one island has all of the same kinds of carbonate chemistry. So that's, you know, we need to be looking more closely and tracking this information over time in order to develop appropriate adaptation responses. On the bottom is just a sort of pan Pacific, Western Pacific snapshot showing, again, that same measurement for different island groups. And, you know, it's not all one thing. And these are multi-year kinds of measurements. So what are the adaptation options for coral reef communities? Well, I would have to say mostly there's a lot of scientific questions we need to answer. And that doesn't mean we can't start monitoring, but we don't know exactly what adaptation strategies are going to work. But luckily, the local response to ocean acidification is to grow the carbon sinks so this is growing blue carbon, which is also a good thing from a global atmospheric mitigation point of view. So protecting and growing seagrass beds, salt marshes, and mangroves. And we're losing those daily, weekly, yearly. So this is yet another reason, because it can have important mitigating effects on the local coral reefs. So one idea is seaweed cultivation, which seaweed traps CO2. If you grow seaweed, the corrosivity of the water is less, and you're growing something that you might be able to use for economic support of the local community. We also have found that the corals that are growing near seagrass beds are more robust because the CO2 is being trapped and taken out of the water by seagrass beds. So another reason that we need to be protecting seagrass beds, because it also has impacts on coral reefs. Finally, we need to protect and enhance mangroves. And this is very interesting new study that has come out that's showing that corals are in fact on their own migrating into the mangrove taproots, there wasn't really a recognition that we should be looking for corals in the taproots until the coral reef ecologists happened to be in the mangrove and saw them there. And so with increasing temperature of water and the corrosivity of the waters that are out on the reef, we're actually finding that mangroves are providing a refuge of sorts. So yet another reason to protect our mangroves. So knowledge is key. Without information and data about both ocean chemistry and how the biology is changing, and that's certainly the more complicated part of it, we cannot know if our adaptation strategies are working. And I'll say finally that New Zealand is investing in OA adaptation pilot projects for Pacific Small Island Developing States through SPREP. And this is a multi-year, multi-million-dollar effort. And I encourage you to reach out either to me or to them if you're interested in that. And just to end on this note, which is through the Go On, we've actually established a new program called Peer-to-Peer, in which we're connecting scientists that are new to the field from developing regions in particular to scientists that have been doing OA work for quite some time to support best practices, to develop training opportunities, to strengthen relationships across countries and continents, both from a science perspective and also connecting policymakers. So I'll end there.
Thank you very much, Libby. Absolutely fascinating. And again, 2 points I would like to take away from this. One is we are all not only about nature system, but about human beings. And you, in one of the slides, you highlighted the importance for people. Let me just say, a few people know that 70% kind is consuming is coming from fisheries. And fishing is, of course, one of the things that poor coastal communities do and keep them for a living. So they are most affected actually by this. And it's fascinating to see, that's my second point, that local measures, which are actually quite low tech, but labor intensive, can address exactly the situation. So if you look into ways of investing climate finance, I think here's a very fascinating model where you can provide jobs to those who are hardest hit and at the same time restore the ecosystems people depend on with a global benefit. And I think that's absolutely fascinating. Our next speaker is passionate about exactly that, the impact of climate change on human beings and how to build more resilient communities. Tania Osejo Carrillo, PhD, is a climate adaptation specialist from the World Food Programme. She has a background in forest economics, and before this meeting, we agreed to slash all the long CVs, not to waste your time, but I just asked one question, what you're passionate about, and Tanya said it's forest and it's about the UN RED system, and I'm happy to give the floor to somebody who is passionate about what you are going to speak to us. Tanya, you have the floor.
Okay, thank you so much, and thank you also WMO for the invitation to be part of this panel discussion. The presentation that I prepared today is more from the perspective of WFP as a user of information. We also produce information on food security and nutrition, but then it's like when we're trying to use information on climate change specifically, then we need some help. So as a WFP user of information that is also in contact with local communities, who are in contact also with governments and so on, is how to try, to use this information, climate information, to enhance the adaptive capacity of food insecure populations around the world. So this is the perspective that I have for this presentation. For those ones who are not familiar with WFP work on food security and nutrition, this is just to give you a brief overview why WFP is involved in this kind of activities. As you can see from the slides, in the last decade, almost half of WFP operations has been, to attend climate-related disasters and post-recovery operation as well. In the last decade, that it costs 23 billions of US dollars. This figure is without, taking into account the economic and non-economic losses of those countries that are hit, let's say, by suffer the consequences of this kind of disaster as well. In 2015, 14.5 million people were participating in our activities of food and resilience, or everything related to climate disasters in general. So climate change for WFP and for all humanitarian organizations are working to achieve zero hunger by 2030. Climate change is complicated. It's bringing this scenario a little bit more complicated to achieve SDG number 2. Together with governments and different partners, including local communities, WFP have been developed more comprehensive activities, strategies, and approaches that it includes how to incorporate climate information into food security analysis that we have at the moment in order to see how can we improve the adaptive capacity of food insecure populations, our target groups, and also increase the capacity of governments to deal with this kind of problem. So when we are trying, to met this kind of activities, the problem that we have is like, okay, we need to assess a little bit the information needs that we have. And first of all, it's like, well, we need to increase our understanding between climate change impacts. What does it mean in terms of nutrition and food security? We're looking beyond food production and we're focusing on the other pillars of food security as well, because it's not only about the production of food, but also it's about the food access, food utilization, and stability over time as well. Many people are asking us about the trends. Of course, we want to know what will happen. I'm going to, what kind of investments or decisions I have to do in the ground. We are trying to develop a little bit of different approaches because the other pillars of food security is not that easy for us in general terms to make it more evidence, the impacts of food access, the impact of food stabilities, and so on. So we are creating proxies and approaches together with our partners, how to measure food nutrition, the impacts of food, the impacts on food security and nutrition. We are trying, to experiment a little bit with climate sensitivities of income sources, different income sources, livelihoods, how livelihoods are sensitive to different climate factors and so on. And many people are also asking us about geographic patterns of vulnerability. So this is part of the information needs, not only WFP, but also all the partners, the governments where we are working on. This map is only to show you in which areas specifically we are working on this lens, in this focus on food security, nutrition, and climate variability and climate change. I'm a little bit sad that Latin America is not there. I'm from that region, but I mean, this is how we are working right now and the focus that we are doing. And the main objective for us is how this information can be useful to inform policy and programs, not only in WFP. We are using this information to improve our intervention, our operations in the ground as well, but also to our partners, how this information can help local communities, can help the governments, can help universities as well, and how can we learn from each other. So it's to inform policy and program design at different level to trigger action in the ground. So I have a couple of examples that I will explain here. You will find more information in our website as well. This is focusing more on climate services and how climate information could be useful to make decisions in the ground with farmers and pastoralists that we are working with. So these are just part of the initiatives that involve climate services. We have, for instance, the Livelihoods and Early Assessment and Protection Project at SLEEP that is financed by the European Union. We are working with farmers in Ethiopia, but also with pastoralists in climate information to bring in information in the most timely, less costly way to make decisions in the ground. We have also the food security and climate resilience, that this is how to inform before a climate event will occur and not after the event. So this is something also how climate services could help with the food security and climate resilience. We have the Rural Resilience Initiative as well, that this is the incorporation of weather index insurance in WFP operations in order to reduce the vulnerability of our farmers that are working together against drought, the vulnerability against drought to be reduced. And then we have a partnership together with different organizations, including WMO, WHO, IFRC, about climate services and a special program that we have in Africa, focusing on Malawi and Tanzania. So these are part of the projects that we have on climate services. I will focus on the last two, the Rural Resilience Initiative and climate services for the chapter that we have, or the special program that we have in Africa. So in terms of what we are doing on climate services, especially in Malawi and Tanzania, we are trying, how to translate very, very complicated climate information in something that is really help the farmers to make decisions in the ground. And this means that the information has to translate it in something that it can be, easily understandable from our target groups, but also has to be provided on time. And it should be the cheapest and the fastest way possible, because WFP is working rural communities, food insecure population. They don't have enough income. So we have to provide even to find the ways, very good platforms that the information can be shared to the lower costs as well. The climate services component is just part of the comprehensive integrated approaches that we have to deal with this problem. What I said before is like, we try to incorporate it in other operations that are running right now in WFP. So it's not an isolated effort. This is the key messages over there. And this means that we need also to work in partnership with different stakeholders. We are not working alone. We are working with the government. Food security and nutrition, sometimes people think about that this is only the Ministry of Health in one country, but this means disaster risk reduction programs, for instance. The Met offices, the Met services in each country also participate, because we need their information in order to provide it to the farmers. So what we did with different partners in Malawi and Tanzania is to analyze the information needs of the farmers. Once we analyze information needs, we see what platforms it will be the most feasible one cost-effective one in order to provide this information. We did as well capacity building in order to, because the information, climate information should be carefully read, you know, is not easy, but also is how to interpret the data and so on. So we have capacity building component for our extension workers in the ground and so on. So the information we are providing to the farmers in these two countries goes, for instance, through radio shows, and also we are using the mobile systems with the message providers there to provide this information. But also we have an interactive dialogue with the farmers. When they receive the information, they can ask also the experts. We have weekly programs in the radio shows when where the farmers can call to the expert in that session of 30 minutes, and this call is for free, so the farmer doesn't have to pay anything. And then if there's something that they don't understand, or they need, you know, this interaction with the expert, then through the radio show that we have in these two countries is working very well. So we are providing seasonal forecasts for the farmers, and we are also providing 10 days season, 10 days also information for 10 days to make decisions in the ground. One of the evaluations so far that we have been seeing is, for instance, for the recent El Niño phenomenon, is the people, they have the information and they did very good decisions, investment decisions in the plot. They changed the crops. They shift crops on things that it was more drought resistance, for instance. And we are now in the evaluation of the whole intervention that we did with the Niño phenomenon, but I have to say that we have very good results with the people, with the farmers who are participating in the climate services, because they did have information on time. And also, weather information is used in the weather index insurance that we have with the Rural Resilience Initiative. Is this area we have here? Yeah, the Rural Resilience Initiative is just a component. It's weather information that goes to design an index that the people can buy to decide the insurance that people can buy this insurance against drought. And then if there's a drought, the private companies can pay to those farmers that are insured, and the farmers can make investments, how to invest these payments of the insurance that they receive to reduce their losses when the drought is coming. So these are the results of the interventions that we have so far with the Rural Resilience Initiative that has the weather index insurance component in our operations in WFP. We started in 2009 with 200 farmers. We started in Ethiopia. We scale up to 4 countries right now. And from 200 farmers, we scale up to 40,000 farmers, equivalent to 200,000 beneficiaries that are participating also of these activities. Part of the results that we have so far is in Ethiopia, the insured farmers, we have seen that save more than twice than those ones that doesn't have any insurance. And the insured farmers also report higher level of investments in productive assets in comparison to those ones who are not participating in the program. In the terms of food security in Senegal, also the evaluation has indicated that after 2 years of bad harvest, our 4 farmers who are participating in the program were able to maintain their food security compared to others exposed to the same risk. And also something very interesting that we saw is like women achieved the largest gains in productivity within the group of people who are part of the R4 of the Rural Resilience Initiative. As I said before, with the Niño phenomenon, we have some very good results that we are under evaluation right now. But for instance, what I said before, that the farmers who were part of the program they shift the crops to something that it was more resistant, drought resistant, in order to reduce their losses. And this is something very positive that we have seen. But we hope to have the final report by the end of this year. Just additional, I'm not going to go into details. Sometimes the governments also are asking for information at national level. This is part of, the patterns. We have to understand where the hot spots are in terms of food security and nutrition. So we are developing approaches on climate risk and food security analysis, incorporating livelihood zones in order to have livelihoods and proxies to food insecurity. So it's what kind of livelihoods are climate sensitive, where are those livelihoods located, and then we try to analyze a little bit the potential impacts from climate change over there. So this is just an example for Sri Lanka. This is part of the analysis that we have of the future trends that we can observe in terms of sea level rise, where could happen, the monsoon collapse and the climatic shift. And also this information is not only information, but also in discussion with the government and key stakeholders. We have recommendations in terms of adaptation activities that can be taken into account at national level, and also can inform different kind of strategies and programs and planning process that are taking place at national level. And finally, this is a hunger climate vulnerability index that it was developed together, in collaboration with the UK Met Office and WFP. This is a global level. It's an interactive map as well that it looks at different emission levels, scenarios, and also look at different adaptation levels scenarios. And the outcome that you will see here is how vulnerability to food insecurity will look like. And we have projections for 2050 and 2080. This is just an example of the future scenario with high emissions level and no adaptation, no investments in adaptation. So lessons learned, and this is my last slide. Partnerships in this kind of activities for adaptation at local level or national level is very important. WFP implements, and WFP is known for the emergency operation disaster risk reduction, but we need information, we need partnerships with university, research centers, with the Met offices, people who are working, in nutrition and food security as well, because the problem is really, really complex, and we need to understand how to address the best way possible. Information needs is important to understand what are the information needs, not only in terms of data, but also in terms of what kind of platform you are going to use in order to spread the information, in which way you have to take into consideration the cost. We are, as I said before, we are working with food insecure population that have very little or no income at all. So how can we protect them to enhance the resilience, to enhance adaptive capacity? So it's very important to understand what are the information needs of the final users of the information. An interactive dialogue with final users of information is very important. Is how to put in contact the expert with the final user information for this feedback, and then to improve all the products that we are developing. Capacity building and knowledge transfer is also very key in our interventions, because the capacity building is not about only to read how to manage the information, but also is integrated component of, land use management, natural resources, water management, and so on. Translation of complex information into a format that triggers action is very important, and we have been discussing this in the past. Institutional arrangements is who is doing what, when, how, where. And this is not very important is on data, data collection. We have problems in different scales of data and so on, but then it's like who is the authority that has to declare, for instance, a drought? Who is going to provide this information, how the information will go to the ground, and so on. So the role of every single partner who is involved in this process has to be very, very clear. Institutional arrangements is fundamental in order to, to put some organization when you are triggering an action in the ground. Scaling up is also very important. What I have presented here is just a few pilot projects that we have. But the scaling up to make sustainable these interventions in the ground is really, really important. If we have been doing this through an active, for instance, a participation of the private sector. The private sector is the one that in some of the countries are providing the insurance services to the farmers, for instance, and this is a way to scale up. And also we are using our platforms that are in place at national level with safety nets and social protections also to multiply the effects of our interventions in the ground. Now we are assessing a little bit how how to incorporate traditional knowledge. This is a need specifically that we have seen in Malawi and Tanzania. The final user of information are asking for this kind of, incorporation of traditional knowledge in the climate services that we are providing. So we will have a second phase in Malawi and Tanzania, and this is our next step that we have. So my intervention stops here. If you have any question, more information, you can go to the website. You can send us also an email. I'm here for any question if you have.
Thank you very much, Tanya. Traditional knowledge, one of the things that people tend to overlook is that most people in the world who are poor are farmers, and they learn how to do business from their parents on the basis of the traditional knowledge. This has worked for many, many generations, but as weather patterns shift, it's not working anymore. And that just makes the case for the importance of up-to-date weather information. So we've seen on the African continent how an entire continent basically catapults themselves into the present just in the telecommunications sector, where you have to go for a long walk in the Sahara Desert to finally find a spot without cell phone coverage. And mobile banking actually was developed in Kenya. Let us not forget that. So I think as a vision, it is utterly possible that the world's poorest actually start precision farming with a GPS-enabled mobile device. That's absolutely doable, and that's not too expensive. Brings me to the second point, and I very much like the framing of the 4R initiatives. It's all about risks. If, in a developed country, you take a wrong decision that might be painful and that might cost you money. But as a smallhold farmer, if you take a wrong decision, that's the only time you're taking a wrong decision, because there's no reserves that help you to fix what you did wrong before. And what crop you plant and what's coming out of it decides on whether you can stay or whether you will be pushed, like so many others, into some urban slum trying to survive there. We did a point landing with our time that gives us exactly 15 minutes time for question and answers. The colleagues from the technical support have roaming microphones, and I would take a first round of your question, let's say 3 to 4 questions, go back to the panel, and if we are all disciplined, we might even have time for a second round of questions. Can I have a sign of hand? And if you ask for the floor, please introduce yourself briefly. Can we have a microphone to the lady in the 6th or 7th row? And you can already give me a sign of hand, so I'm addressing a speakers list, okay?
Hi, I'm a student representative of the American Chemical Society here this week, and I'm particularly interested in science communication, so I was really impressed and excited to hear all of your presentations. I wanted to go back to the comment that the moderator made about connecting with urban versus rural populations, especially in the US. We have as we saw the other day, the large division in thought processes and in a lot of ways between our urban and rural communities. So I'm wondering, you talked a lot about engaging cities, and I think that's definitely a great way to move forward, but I'm wondering if you, particularly the first presenter, if you see any, if you have any ideas for how we can better engage, particularly for me and other students going back to a country that has a lot of problems in engaging across these boundaries, and maybe for the other two presenters, if you have comments on that issue at all.
Thank you very much. And if you turn around, the lady behind you is asking for the floor.
Hi, thank you. That was really enlightening. I'm Ana Queiroz. I'm representing the Marine Ecosystems Research Program and Plymouth Marine Laboratory in the UK. And my question is for Dr. De Cola. So at this time of fast political change, one of the examples you gave about science informing policy was from the Department of Energy and Climate Change in the UK. Now, since June, we no longer have that department, as you know. We now have the Department of Business, Energy and Industrial Strategy. So in your position in IGIS, my question was just about whether you could provide some insight into how these fast changes may or may not be affecting this process of evidence providing. Thank you.
Okay, while I would encourage more to ask questions, maybe I give directly the floor to Phil to answer the first two questions. And we are eager to take your questions to all of the panel.
Thank you. To the first questioner, thank you very much. A member of ACS also, so my undergraduate degree was in chemistry. And so my first question, I have a question for you. So you're going back? You decided to go back? I think I'm going to stay here. Yeah. So what can you do? What can anyone do? In relation to the dichotomy between urban and rural, I really don't have any immediate thought about how to bridge that gap, other than our nation needs to stop paying lip service to the importance of education in our country and really start to really, pay heed to it in a real tangible way, instead of just, doing what it has been doing on both sides of the aisle, Democrat and Republican, in a two-party world that we live in the US. But with regard to Martin's comment, I see the urban, certainly urban centers are existing on the pillars of ecosystem services, right? That are holding these large settlements up. And so while, the quality of life in some large settlements is quite good, in others that are growing rapidly, it's not so good. And that can be both endogenous and exogenous. It really is something that, while I see the urbanization of the world as a opportunity to have an existence for people that's quite high quality, I think that the information that we need to both manage within that settlement has to be one, and then we need also, of course, not to neglect the rest of the planet, because the cities don't exist as islands. That they need to have a vibrant ecosystem service. So in terms of what a student or a postgraduate can do, any individual, I'd be happy to discuss that with you in detail, because there are a lot of opportunities, and some of it has to do with citizen science. Martin referred to the power of individual actors within the African continent on the basis of the connectivity that we have and the information that we have in our hands. And so there's quite a bit that we're envisioning within the IGUS initiative in that regard. So we'll talk about that. And there was the other question, right?
Yes.
And in terms of BEIS versus DECC, yes, I'm familiar with the transition. And when I first heard about it, I was upset and concerned, but then I was assured by my UK colleagues that it's really, even though the words Department of Energy and Climate Change no longer are in lights, those same priorities and activities haven't changed as of yet. Those people are the same people, the initiatives are the same initiatives, they're being managed under an umbrella that is business, as you say, and innovation. You can call it what you want, as long as they maintain the objectives that they have, and to the best of my knowledge right now, those objectives are still the same ones, and in fact, the leadership are still the same folks in terms of the real worker bees, the people who are doing the things. The figureheads have changed, but the machinery is the same.
Thanks very much, Phil. Let me add one thing, and I'm taking that from Tanya's presentation. The need to translate complex scientific contents into language that people can understand. And I think that is where we often fail in really clearly communicating what it is about. And, you know, we have a whole generation of digital natives who are just brilliant in expressing the most complex things in 160 characters. I can only encourage you to do that, you know, tweet until your finger is down to the bone, spread the message and work on visualizations, because that is actually what works. And on the point, urban versus rural, what I find fascinating is real rural people depend on natural resources much more than urban people. And they feel the impact of climate change. So it's a bit of a hypothetical discussion about, you know, whether it's happening when you actually have a crop failure every second year, and somebody has to connect the dots. And I think that's our job. Are there any more questions? If not, I have the fantastic privilege to ask you two things I wanted to know. And the one is from Libby's presentation. One of the things that I find fascinating is in an enormous ocean that there is actually even space for local action. I found that surprising, and my question to you would be, what's the limit for local action? How much can you do in an ocean that's getting increasingly acidified? And then I have a question also for Tanya, but let's go for this one first.
Well, before I answer that, which is not really known quite yet, I do want to come back to your prior point, which is one of the things we're finding in the United States is that the rural, that the fishing communities, which tend to be smaller communities, not city oriented, the fishermen are actually some of our strongest advocates, and advocates for the science. They see the changes happening out in the ocean. They know, they see the fish moving north because temperature is changing, and they want to know, they want to be able to, you know, plan their futures. And so I think there's remarkable sort of progress and progressive thought within those communities. You just need to connect with them, you know? So as far as local adaptation, I think it's a good news story, but it's hard to know. We're still, you know, early in the science. And as I said, so New Zealand is funding some work in the Pacific Islands. Those will be some early pilot projects. But we still have so little monitoring happening that without the monitoring, we actually can't tell if the adaptation strategies are having an impact. So I would say stay tuned, you know, maybe in 1 or 2 COPs from now, we'll be able to speak more succinctly about that.
Thank you very much. And Tanya, that was already foreshadowed. The last point you made, and we were short on time, but I want to come back to that, traditional knowledge. What have you learned? Can you give us an example from in this work where actually traditional knowledge, people on the ground have taught you a lesson?
Well, maybe, can you hear me? Yes, okay. The traditional knowledge, so far what I have, the interaction is mainly in Central America at the moment, and then it's how, you know, can use traditional knowledge to storage some of the food that it has been forgotten for some indigenous communities. But then if you talk to the people, the elderly, you know, if you don't have refrigeration, like a fridge or something like that, for instance, is how the elderly used to do it in the past, for instance. So this is kind of traditional knowledge so far that in Central America is something that, okay, people maybe have forgotten, but then it's like the new generations are learning from the past as well, how to do it with the lack of resources that we have at the moment. In the case of the climate services in Malawi and Tanzania, I don't have that much information because now that our beneficiaries had expressed their concerns about it, we are collecting information from the final user in order to draft the second phase of the intervention. But this is just a very, very simple example of how, you know, you can use this traditional knowledge that maybe is forgotten, but then you can bring it back to improve the storage conditions in very limited and remote areas, how to do it in the proper way.
Thank you very much. And before we conclude with this session, coming back to social media, I just wanted to share with you the Twitter accounts of those on the panel. I don't know, Tanya, whether you have an individual one. I'm sure about the WFP, but please share yours.
Yeah, we have an WFP COP22. That's the one.
Fantastic. Libby has a Twitter account that's very easy. It's at Libby Jewett, as in the program. Phil's is very easy. It's PD Cola in one word. Mine is CMFRICK. And all the institutional partners you will find. There's at WMO, there's at FAO Climate, and we would be very happy if you spread the word. Please join me in thanking our fantastic panelists for a fascinating session. Thank you very much.